Today, everybody, Brian here. Today is July 8th. What I'm about to show you is very critical to understand, to know how to break through the world of high frequency trading, programming, and if you want those highly paid 7-digit jobs and be valued for what you do, I've already put up over the last number of weeks, days on how to survive and thrive in this field and what you can and cannot do being an independent trader, consultant in this rapidly changing field. Now, I am going to start here very easily so people understand what we're getting into. If you want to get in high frequency trading, we're talking real high frequency trading. Listen up. If you're just I call them hot dog marketers, basically, those that sell hot dogs in the street, the ones on Instagram, TikTok, and the like, don't know how to program. They're not HFT and shouldn't be not even mentioning the word HFT in any of them, but they're just, we know, a bunch of schlocky people. Secondly, if you're coming from the world of JavaScript or whatever other easy to understand, including Python, what I'm going to show you is very critical to understand the concepts of true high frequency trading, specifically, as you can see here in this paper, low latency applications. Now, first of all, I want you to pay attention very carefully. This is on obviously LinkedIn from this guy, Dimitri Swan. I don't know who he is. He's second level to me. I don't care about that, to be honest. But at the end of the day, he's a software engineer at Google, back end, infrastructure, cloud, and open source. So these kind of people I'd probably pay more attention to than what you see online when it comes to YouTube. Very important to understand that, because if you don't, you're wasting your time and you're not dealing with people with real credibility and have a real understanding of how this stuff works and how to get the attention of recruiters when you have this kind of knowledge on your resume. If you don't, and I keep saying, if you don't have the Ivy League school behind you, I'm not saying it's not possible. It is possible, but you got to showcase these type of knowledge to get these type of jobs. So let's get to it. So again, this is an HFT paper. Um, if you have an interest in HFT system, C++, you might be interested in this research paper. Design patterns for low latency applications, including high frequency trading. This paper admits that many tricks are trade secrets. This is important because this is the sort of stuff that people don't go on about. I know about it because I've been involved with people that make like a serious lot of money that start hedge funds. One person I can put on my channel, just look up London Quant. London Quant on my channel. You'll see what I mean. That said, the author extensively reviews the landscape of this domain and provides insights, concrete examples, and a code repository for review. These are even some mentions of Rust. We've already talked about Rust in another video quite recently, but this one, I hate to tell you, is purely for C++, and I'd say 95% of all those jobs are going to be in C++. You can see here who they're from. These are from Department of Computing, Mathematics, and Imperial College. That's a pretty Ivy League school. Same thing, Imperial College, Department of Computing. These two guys here. Okay, so first I want to introduce you to the comments. These are the high level. We're going to go whacking in the weeds in a bit. And if you clearly don't have the concept, the initiative, the drive, nor the motivation, you're in the wrong business, folks. Yeah, you're definitely in the wrong business. Okay, and I would pursue other fields of interest. Okay, so I hate being the bearer of bad news like that, but this is how much motivation and demonstrated motivation with demonstrated results you need to have. Okay, so this one is an interesting one. These are all the different styles of C++ programming out there in this chart. So here, it's not maybe better to do this way. Right here. So right here, just one slice of example. If we do things to optimize the technique in the models, how the data is captured, how it's processed, and how eventually there is trading execution on the price, these are the different techniques you can use to speed up that. And one of them is this cash warming by 90%. Another one, construction expression. And again, if you don't understand these, not willing to put the effort into understand these at the low level to master it, game over, folks. Game over. It's going to be hard to break through when you got thousands of people applying for that job. All right. So again, good to see some paper on this topic, and there's a lot of them out there. You'll see at the bottom of this particular one. Still fails a bit moot on its usefulness. I find that bonkers for that statement. Not many people talk about it. Disruptor has huge similarities. Most of the networking stack code, and the rest is just something anyone, even a bit info performance knows, quote unquote. They refrain from discussing data feeds and efficient processing, which, in my opinion, is a cornerstone of achieving low tick latency. True, but this I'm showing you is just a taste of what is needed, and you'll be competing against the nerds that are involved in this and are masters on this information. Also, some of the explanations for why optimization work is incomplete, such they don't mention how load store reordering coalescing helps in case of loop unrolling. Do you understand that? Okay, this author did his best. He was in academia, and I've always said that about the R folks. They're stuck in academia, criticize anybody else in the private industry making a living in trading, but yet they've got the cushiest job being in academia. Happened to me. And admitted to having limited information available. If they use TradingView, you could probably get a different story, as I've shown in one of my videos. Make sure you watch and show your interest in those topics. That said, the paper supplies additional value. Performance optimization techniques here because it introduces a few domain aspects specific to HFT. If you don't have experience in that industry, it's useful. Agreed. And that's why I'm doing this video. I guess that would be true. It will still be beneficial for uninitiated into the fintech and low latency application. But the guy says it's an awesome share, and it is an awesome share. Okay, so here, interesting two areas to go down: fintech or other low latency applications. The military would use this, scientific would use this, medical will use this, and fintech. But if you want to be the best paid programmers in the world and earn the highest paid internships, you be in the world of finance, bar none. So this guy says gold mine, calls this a silicon mine. I don't know what that means. New profile, blah 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 blah. One of the best pieces of advice doesn't seem to be mentioned in this paper. Avoid dynamic memory in the critical path. So this person's very experienced, obviously. This is complete basic and low latency development. But you'd be surprised just how many devs in the trading industry fail to do this properly. Again, you got an insider now revealing their own topic or their own knowledge. Simply put, it's hard. Dynamic memory is just an additive to use. It's like a drug and makes programming so much easier. It's hidden in many of the libraries calls you are making and APIs you use. One thing I will tell you, many HFT firms will write pretty close to 100% of their own libraries and not use very little, very few third-party libraries because they want to optimize the code that they need. And remember, a lot of the real big HFT firms that you know have nobody but PhDs in math, physics, and computer science. That's why they are able to build out their own libraries, uh, working in the fields, and nobody knows. So to have this kind of insight is very rare. Uh, Senior system analyst at Ideal CTVM. Oh, the other guy here, I make stuff in C++. Okay, whatever that means. And one thing I'll say about these people is a lot of them will not talk about where they're from. It's like being a spy in, let's say, the CIA or one of the three-letter government agencies, and they'll just say defense. That's it. It's the same when it comes to HFT. They'll just say trading, and that's it. They don't know what company they're with. So a lot of these people probably are on the inside, but you don't know what company they work for. It would go against their non-disclosure agreement, in fact. This HFT stuff is interesting. Keep sharing cool papers like this. Thanks for sharing. Very informative. Okay. Are you ready to be confused? Let's see what we have here. Okay, let me just download this here. And here we go. This is what you'll end up downloading. Okay, here it is. Now, big picture here. It's only 50 pages, so it's just giving you tastes of concepts. And as I said here, let me just go to the bottom here. If you want to go down a rabbit hole for many months and many personal sacrifices, this is where you go. Go and look at the references for all of these different places to go to see where all these concepts come from, probably in further detail with what I'm about to show you. Now, a few things about languages here. I think they've done a pretty good job on explaining languages. I've explained that in other videos as well. So let's get to it. This is going to be a long video. And in fact, I think this is an important video to blow out all the misconceptions you see that are on online, be it social media, other YouTube channels. Because if I'm not showing you stuff like this, they don't know what they're talking about. They're just using HFT as the marketing buzzword to basically scam you for whatever they're pitching you, whatever trinket they're offering, or whatever low level service they're offering you. All right, so let's talk about languages here. Everything that's going to be talked about are two things I've mentioned before: Linux and C++. Those are the areas of focus. Now, in here, they do a pretty good research and explanation why Python is kind of not used right here. This is the language. So this is the language they use, C++. Now, again, there's lots of introductory stuff we can go through. But when it comes to languages, uh, here you go. Low latency applications, as the ones utilized in HFT, tend to prioritize compile time overhead over runtime overhead, making compiled languages like C++, Java, and Rust more suitable. Where have you seen that before if you've been watching my videos? Because I said the same thing. And you're also not seeing C# in there as well, or any of the .NET Core stuff or .NET stuff as well. No Microsoft, because it's bloat, 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 bloat. And that's what HFT is not about. So here's Python. Very well suited for such applications due to its interpreted nature as it introduces runtime overhead. C++ is the one of the popular choices for building software-based HFT systems. Do I need to show it any further? I probably won't even say this again. So C++ is the preferred language. C++ is the higher paying language because it's one of the only languages that does any of this. What does it say about Rust? Rust has emerged as an upcoming alternative to C++ in recent years. Offers advantages such as memory safety, concurrent support, developer productivity, performance, and a growing ecosystem, making it an appeal choice for HFT systems. C++ gained popular in performance-driven industries due to its zero overhead principle. Very important here to understand why C++ still rules and always rule till the day we all die. Principle is broad term that it can be witnessed though many ways. For example, does not have a garbage collector. That means programmers must manually allocate and deallocate memory, which leads to a more efficient and deterministic, predictable memory usage and avoids unnecessary overhead. Voila, which is what garbage collectors are. So you can't live in a world of convenience to really get optimal performance out of C++ or whatever language you're using. Worth noting that Java has been successfully used in latency critical applications such as LMAX group with the Disruptor. That's pretty revolutionary, but that's only for Java and blah, blah, blah. I'll let you read it, but you can see here why C++ is the language of choice. So outside of that, what we're getting into, first they talk about the LMAX Disruptor, the different design patterns. And I've talked about this before, and I guarantee you, you probably never heard of these patterns. And this is specifically for C++, cache warming, compile time dispatch, construct expression, loop unrolling, short circuiting, signed or unsigned comparisons, avoid mixing, float and doubles, branch prediction, reduction, slow path removal, SIMD, single instruction, multiple data, prefetching, lock-free programming, which I would think is one of the better ones, and inlining. So it talks about LMAX, the disruptor, the chart, blah, 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 benchmarking, how it's done, and Google benchmark. And remember, the person that originally posted this was from Google. Okay, so this is an open source Google benchmark for HFT environments. I've never heard of this, to be honest. Google benchmark is used statistical rigorous methodology. Library systems, multiple iterations of specific code snippets or functions, thereby generating accurate performance metrics. Such precision in performance measurement is critical in the context of HFT, where the software stack efficiency can directly influence the trading strategy's efficacy. Don't need to say more. This is the other important thing is the performance in Linux. Performance counters for Linux, not Windows, Linux is a sophisticated performance monitoring utility that is integrated into the Linux kernel, not WSL, Linux. Provides rich set of commands and options for profiling, tracing, software performance, system events at multiple layers from hardware to application level calls, function calls, blah, blah, blah. So we have here cache analysis. This is very important here. Goes into this chart design pattern for low latency. Again, C++ only, maybe even C only. Then it gets into the networking. Have I lost you yet? Low latency networks are the linchpin of high frequency trading. So you have to know how to hack a kernel, a Linux kernel. Not a key aspect of the work is still important to inform the reader with the basic understanding of surrounding pieces of complex HFT. Blah, blah, blah. Co-location remains critical strategy for HFT firms. I'm not going to get into that. It's all here. I'll give the link where it's available. Low latency programming repository. This is where it gets important, as I showed earlier in that chart. Cache warming. I've mentioned this before about L1 cache and L2 cache. It's handled differently, and main memory management. This is the low level, whacking in the weeds stuff that you have to be a real nerd to get around to understand the different throughputs on the data cards or the network cards. If it's on an SSD drive, where all the data is stored, and so on and so forth. Is it in memory? And so on and so forth. Market data, strategy, execution engine. So these are different design patterns. Again, that are very specific. Flowchart of cold cache. This is your warm cache to get that 90% boost. Market data, strategy, execution engine. When it comes to the execution engine, you're looking at protocols like Fix. There's a few out there that are paid. You pay maybe 10,000 a month for it, for those Fix engines. So execution and probably most likely is built in-house at these firms. It could be for those that may not be able to have the resources to do that, would actually use one of these third-party pricing execution engines built in to, and that has direct connection in a variety of different exchanges, CME and the like. Cold cache, Google benchmark, blah, blah, blah. Here's the code. As you can see here, the different type of loop. And again, all of this is very different from what you've seen in other languages. This is not your daddy's type of high level programming like you would get in, dare I say, Python. It's just not capable of doing. Cold cache test took approximately 267 million nanoseconds, while the warm cache was 90%, 10% of that took about 25 million nanoseconds. So this is where it gets very important. All the different techniques, speed and nanosecond, BM cache cool, BM cache warm, instructions, blah, 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 blah. This is now getting into the area of high frequency trading and how to optimize all the different things about it. So we have here compile, time, dispatch. Two techniques. Again, when they say all the brainiacs call object-oriented programming is dead, it's not dead if it's being compile time dispatch. Two techniques in object-oriented programming. You will also find when you get in this field that there's going to be 20 plus years programming concepts that will not die in these firms and shouldn't die, nor they're going to hire some 20-year-old brainiac kid that thinks they're mightier than whatnot, and then they're expecting their employer to replace all their frameworks and libraries. Ain't gonna happen. So they're stuck in the world of 2000, let's say, or even the 90s or the 2005. That code is not going to change. Runtime dispatch, dynamic dispatch resolves function calls at runtime, primarily associated with inheritance and virtual functions. That's classic object oriented, and it affects the runtime and compile time dispatch used in conjunction with things like templates and function overloading. That you get in the world of C++ only, mostly C++. You can kind of do it in Java as well. Benchmark difference, 2.6 nanoseconds, 2.15 nanoseconds for derived and derived to respectively, in all of this fun stuff. Okay, const expression is a key word in C++, facilitating the evaluation expressions during compilation rather than runtime. Again, as I said earlier, compile time is more critical than the runtime. Advantages lies in enhancing performance by computing values at compile time to make it smaller, more efficient in the execution code during runtime, obviating the necessity of runtime computation. So the compiler matters, how you write the code, and so on. You need to use these tools like Google Benchmark, which I've never really looked at, but I didn't realize it's so important in the world of HFT. Particularly helpful for constant expression with the values determinable at compile time. Computation at compiling using C++, const expression, keyword, and conventional runtime computation. So here's the code: const expression benchmark, Here you put in your nest in the benchmark right here from the Google benchmark. Okay, blah, 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 and then more blah, blah, blah. Now, hopefully you're still with us. These are just different ways to optimize. This is just one slice of what's needed in the world of 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 HFT, low level C++ programming. You have to be a brainiac doing this. If you're still here, you're pretty smart, or you're motivated. Okay, so here we talk about inlining. Directive attribute, particular instruction for the new compiler collection, GCC, guiding the compiler to persistently inline the designated function, irrespective of the optimization level chosen. Again, you can do this through the GCC, the compiler at compile time. Results that the function utilizing the inlining directive exhibit faster performance, averaging 1.9 nanoseconds per operation versus 2.39. So here denotes 20% boost, enhancement of speed. Things like this matter. Things like this very much matter, especially when it comes to nanoseconds, competition for trading opportunity. That is why this is so critical. If you're not interested, bye-bye. So I hate being like that, but it's just important that people understand that. So here, more charts, performance compares for compile runtime features. Again, I'm going to be honest with you. I'm not into this, but I'd like to be into this, but I'm just trying to show you how important it is and what you need to know. Loop unrolling technique using computer programming to optimize execution in loops. So you're trying to cut down on your looping. Decrease the number of conditional jumps for the CPU to make. I can tell you some of the analysis is done where they will analyze this and throw it and see how the assembly works. They'll look at the assembly results, and they can on the processor be able to reduce the processing and cycle time needed to process certain type of looping, and it matters, the style of looping and the style of coding. So here you go, static void with unrolling method, looping without unrolling. So in here, we have loop unrolling. This is something I'm not seeing before. It's probably similar to Python. And again, here and so on. Here's the inner of a loop as well. All right. So again, I'm not going to get into the benefits here, but it says the loop unrolling resulted in an improvement by 72% just by knowing the coding techniques that are needed for this. And these are things that you'll never learn in places outside of HFT for low latency applications, because you won't know. Short circuiting. This is really important, and it's also important in the world of C as well. Short circuiting is a logical operation programming with the evaluation of Boolean expression stops. Logical OR, like this. A, if A is true, da 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 da. B, overall expressions already determined to be true. So what you're trying to do is you're trying to cut out the result instead of checking if it's false. And right there, you're cutting down your programming time. So you could probably take a few assumptions there and how you do these logical testing. And again, this is what matters here, the number of iterations it takes on the CPU or cycles to do this, because it results back down to nanoseconds. Non-short circuit, short circuit. So again, if you do and follow the style of short circuit, this is important. Again, you can see the improvement here of C++. But the question is, does Rust do this sort of thing? If it's going to kind of have the abilities to take off and be a mature language and eventually displace C++ in the world of low level, high speed applications, including high frequency trading. So we have here slow path renewal from the hot path can significantly enhance latency in code execution. Hot path refers to segment of code that is frequently executed. Now remember, folks, we are just on page 16. We are not even on halfway. I could go on, and I'm probably boring you to tears, but bad design right here on your if loops. So here you got to use as I said, the C style is so important right here, with that exclamation being not, and then running your different functions from that. That is, as I said before, C style programming. If you know how to optimally write that at a low level, you're doing pretty good right out of the gate, but there's a lot more you need to learn. Okay, slow path, 10% of the time. Slow path operations sent the client removed from map log are executed directly. Yeah, so knowing and mastering a Kernighan Ritchie framework in C helps you get there for this type of path. It's really more important to really understand C low level and how to make it faster, and therefore you will become a much more efficient C++ programmer as well. This paper here is so critical to understand the different concepts. So here, as an example, if okay, hot path versus the slow path, and it goes into that. I'm just showing you the different styles of coding here. Okay, and again, the different benchmarks here are important. Branch reduction. Okay, so here we have bad design, blah, 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 with all these if ends, or if, else if, else if. No. If there's an error flag, handle it, or just go through your, I guess you call it your hot path. And then there's all these different types of analysis here. Prefetching. Right here, technique used by computer processor to boost the execution performance by fetching data instructions from the main memory to the cache before it's actually needed for the execution. Anticipates the data needed for ahead of time. Remember what I talked about, main level memory versus the two different levels of cache, knowing which one to run and to run it faster, and running everything as much as you can within memory. So right here, to fetch it from the lower, slower main memory. Okay, so you want to run it in the cache. And again, you have to get rid of the bloat called Windows, anything that has a GUI on it, like classic difference between Ubuntu desktop and Ubuntu server. Ubuntu server has no GUI on it. And that's the sort of thing, it's competing against all those extra processing and cycles to process the actual overall GUI interface or graphical user interface. You have to have it that bear down minimal. So with the prefetch and knowing when to use it within the cache is very, 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 very important. And it's a standard, it's just the way it goes. Data handling, signed versus unsigned comparison. Which one will be faster? Again, this is C-level stuff. Signed versus unsigned referred to whether binary is capable of representing negative values. Signed means the binary number can represent both positive and negative numbers. And unsigned means it's only positive. Again, you can only really learn this in the world of C. I've been there many decades ago, and it's a fascinating world, but it's easily forgotten about because of things like the internet and beyond to build your phone and all the apps that go on it and on top. But when it comes to the low level stuff, this is what we're talking about. Benchmark test was conducted. Speed difference between signed integer versus unsigned. Loop operation with a value of I incremental by 1 to 10 iterations, two functions signed versus unsigned were created. Blah, 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 blah. Which one's going to be faster? And again, remember what I said. When you start to look at the assembler being generated out of C and C++, there are tools in Linux that do this. You want to see the less assembly versus the more assembly. So here on the signed left, we have less processing at the assembly level, and that's what your process is reading these cycles. So in C, this is what you want to see: less of a smaller amount of code, a smaller amount of assembler versus more processing because it's got to do more checks on the negative side versus unsigned. And again, this is all versus all the different types of code. Again, this goes into this. So here you can see again using the Google benchmark, we have average execution time of 0.321 nanoseconds. People go, what does that mean? You gotta understand the nanoseconds is very critical. Indicates that based on the specific benchmark results, signed integer instead of unsigned led to a roughly 12.15 improvement. So using a signed integer versus unsigned led to a 12.15. Uh, I just want to make sure I understand what I'm saying here. Signed, okay. So I'm trying to understand this logic here. Even I'm gonna admit I am like blown away on this because I've never gone into this. But if this is saying that the unsigned on the right is faster than this, boy, I can't explain that. But again, I've done the C many decades ago. I'm going to be out of touch on it, to be quite honest. But when it comes to the assembly, this I will never understand it. I'd like to understand it, but it's the assembly though that's generated to compare how the assembly works and how it's faster. But when it comes to things like 12.15, you will be expected to know this stuff, and as I said, master it at the level of in a high frequency trading shop. And this is just purely computer science techniques. So here we have the CMB, SBB, and bitwise operator and operator part of the compiler's attempt to handle this scenario correctly. Again, I'm not going to get into this, but this is a nitty gritty we need to know. That's why I call this whacking in the weeds type of stuff, because this is what it is. Different data types. So if you got to use a float versus a double, which one's going to be the faster one, the float or the double? Unsigned and signed matter. This is just pretty. So performance comparison to data handling. So the signed is better than the unsigned. Okay, I can't really. I'm not going to get into that to understand that. Not in this video. This would be a video going on for days. So here we're looking at concurrency. We all know that concurrency matters. So SIMD, single instruction, multiple data, parallel computing. So now we're getting into things like parallel computing. And then when you look at the likes of NVIDIA GPU cards, this is where it could get interesting. Modern CPU offers built-in support for SIMD operation. So your motherboard matters, your processor matters as well. There's a website out there. I just can't remember where it breaks down the very low level analysis using C++ and the types of motherboards. There is a site out there that focuses on this, and I can't remember the name of it. Sorry. So these are the different, it's a different style of programming. That's all I can tell you. Lock free is another one. Lock free is a concurrent programming paradigm that centers around the construction of multi-threaded algorithm, which, unlike the traditional counterpoints, do not employ usage of mutual exclusion mechanisms such as locks to arbitrate access to shared resources. So we're trying not to lock resources to prevent data colliding and processors to collide and then throw off the results. That leads into all kinds of bugs. Um, so again, we have here different techniques, hence improving systems latency and throughput. That's the key word here, throughput. And that's also on the network card as well. Lock free, and it's employing low level synchronization techniques as compare, swap, load link, and store conditional. Again, this is even goes over my head as well, but I'm just trying to highlight the importance of understanding this. Again, we're not even halfway. I could go on and on and on. And again, we have here at the Linux level kernel bypass, all the different models, all the different types of design patterns to be used, which one's more efficient, and here you go. So speed improvement by optimization technique. Again, this is just technique. So we have here the cache warming uh, const expression right here. And those are the ones that boost. So here's the results for the types of strategies we're working with now too. This is where it gets very interesting. Um, so simple arbitrage again, typical trading strategy. We have a co-integration as well. And we also have the real quant stuff. The quant researchers will pull up these kind of mathematical formulas. Again, really important here. So let's see what it says here. Multiple US equities were tested for co-integration over 5 years with daily price as intervals. Goldman Sachs, Morgan Stanley, Yahoo Finance. To connect the co-integration, we use Engel Granger modeling technique, stats model, Python module, blah, blah, blah. We also have here ordinary least squares model typing, augmented, Dickey, Fuller, along with a test statistics or T statistic. Do I have you still? This is all low level. I'll say low level, high level. Everybody should know quant modeling. P value. This is the probability. Measure a probability that null hypothesis of the test, no co-integration is true. Now, as I said before, if you want to understand this, go to MATLAB. They have excellent resources to show you how this is done at a high level. You will not, I don't think you'll find this as easily as you will in the world of Python because Python's free. When it comes to the paid stuff, the commercial stuff that you pay for, MATLAB will have excellent documentation around this. This is again what uh, quant firms use, but they take Python, MATLAB, or whatever at the high level, and then rewrite it and and put it into the type of techniques that I've been talking about in this research paper. So here, p-value 0.05, low p-value allows uh, us to reject the null hypothesis of no co-integration. So just doing that simple test that I've talked about before enables you to see if you have co-integration between two assets. Okay, so these are Engel Granger, Johansson, Dickey Fuller, different statistical ways to measure co-integration between two assets. So again, here we talk about the different adjustments sort of thing. This is what you need to know just as the high level basics entry into quant strategies, not what I just saw from some guy on. Well, actually, the Black-Scholes model is important and the different techniques to attack it. Um, but again, it's more than that. That's just the bare bones basic. This is the same thing. And if you want a job, you got to show your own modeling techniques and show the relationship between this and that and why yours is better. And if you want to even get a job, you have to show the live trading techniques with this to show that. Okay. So I've talked about that. So concurrently, the standard deviation serves as an indicator of the spread's volatility, thereby providing insights into risk and stability. This is now quant math, basic quant math, basic quant math. If you really want to get into the nitty gritty of this, go read the Wilmont Guide on Quant. That's the godfather of all mathematical formulas and equations used in the world of quant, because it's Paul Wilmont, that is a Bible that will get people started to really understand quant. It's 1,800 pages. If you can read that, apply the C++ techniques, the latency, the networking, the low level. I mean, this is how you get into these jobs. Show that you know it, you master it, and you can demonstrate it, because you will be challenged by PhDs from MIT, Stanford, all the like, to see if you really know what you're talking about. Okay, here I've talked about the Z score before as well, another important metric. The Z score, let's see if there's a meaning of it. Let's see here. Yeah. So Z score algorithm employs parameters in a standardize the current spread, culminating the derivation of the Z score. It shows the Z score over 5 years. The formula for calculating is this. But this is not very complicated stuff from the math side. Again, you can chart it. Okay. Again, these are very simple mathematical techniques on top of the C++. This is an excellent research paper to really start on really what quant's about, really understanding not just the research from it on the mathematical front, but also the programming side of it. And again, we're only on page 27 of 50. So here you can see the long and short opportunities between, as an example, Goldman Sachs and Morgan Stanley. Blah blah blah. We get our usual world famous Sharpe ratio and all that fun stuff. And you have pretending to have a portfolio of 1 million, and then we get a return over a certain period of time, which means our Sharpe ratio is this. Not it's okay if you want to get attention. If you get the attention of having a Sharpe ratio of more than 2, you can demonstrate that in your, as I said earlier, another video, in your verified trading track record. You will get a job, no problem, no problem. But you have to prove it, and using these techniques. So here are, it looks like, the portfolio balance over time. Lots of volatility in there. Da 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 da. Over time, no trades are open. P&L looking pretty good. Again, I've shown in the past tear sheets. That's what the big time portfolio managers use and look at. So let me see if I can pull one up. Let me just pull one up here. Just as an example. Let's see if I can find one here. These are generated hopefully in the last few trading sessions. So, okay, let's take a look at, I don't know, Asia as an example. So these are tear sheets that people want to see. I generate these because this is what portfolio managers look at. And these are the metrics they'll apply right here. Okay, so this is a typical tear sheet. So we have our performance, we have our benchmark, our strategy, what I just showed you in the research paper, all the different key performance metrics, all the quantity stuff we're talking again. Sharpe ratio, probabilistic Sharpe ratio, smart shop, Sortino, smart Sharpe, smart Sortino, da 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 da. And Sortino is the difference between volatility, high volatility metric versus a non-volatile metric. And then you get into max drawdown. And again, you don't want to see more than negative 15%, longest drawdown days, so on and so forth. These are what portfolio managers are looking at when they measure your strategy and your trading performance. Then they start looking at all the Greek stuff, skew, kurtosis. I mentioned before R squared. the volatility. They do like low volatility. Kelly criterion, risk of ruin, all the standard quant metrics that are out there, and even more. Payoff ratio, payoff profit factor, tail ratio, and all the different types of returns on different periods. We've talked about the distribution, fat tail. Oh, here would be fat tail, drawdowns. And again, daily returns, similar to what I just showed you in this this chart. So this chart just represents one way of looking at your performance, but using all these different techniques. Rolling volatility, rolling sharp, rolling Sortino. Your drawdowns, most of the people will be pretty horrible. But here's your monthly returns since this started 2008, return quantiles, and so on and so forth. So you get an idea what a professional portfolio tear sheet will be looked upon for metrics to be measured. Uh, if they're going to hire you based upon your trading strategy performance, or if you want a job in that firm. Okay, continuing along. Again, we're now at 30 out of 50 pages here. So we're looking now at the optimization, how to optimize this. Okay, so we've already looked at the quant mathy stuff. So these are your different methodologies to calculate the mathematical, the mean, standard deviation, the current spread, the Z-score. These are different metrics that would be used overall to measure performance of your trading opportunity. This is why things like Monte Carlo is important for Monte Carlo simulation, and I have to have a really peppy set of hardware to pull this off. So here's the calculations using C++, using calculations in SIMD, loop, and unrolling. So this would probably be your typical HFT code right here. Okay. So that would be your C++ HFT code with hand-built in-house libraries. And usually the typical math they use is mean, standard deviation, very simple math, nothing complicated. And as I said, they'll measure the spread, the Z-score, and the like. And the areas they more play in or invest in is options. And as I've shown you, that's where the Greeks come in and the measurement of the Greeks. Right here with the kurtosis and skewness somewhere in here. Right here, skew and kurtosis. So again, these are the different types based on latency and improvement. And this is just running a strategy in probably sub-minute, I'll say, and the different techniques for optimization using that typical strategy. So here we've got the disruptor, the different components of it or concepts on the disruptor as well. Weight strategy, sequence barrier, event processing, ring buffer, producer, sequencer, blah, 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 comparison. Here's your typical Toad demo, I would imagine. Simple Q benchmark. So this is simple stuff. This is introductory level stuff. And again, we're using our Google benchmark here and the results, the Q speed. Obviously, the lower, the better, the faster. Go away. Okay, so now you have your evaluation. All this is explained here. Average score, lowest score, highest score. And this can all also be pretty well automated. We haven't even mentioned machine learning concepts, and we've not even touched anywhere close to AI, and nor have we talked about parallelization and concurrency to make this a better solution. But you can see why they make a lot of money. Reproducibility of repository trading evaluation. Again, so they're going to look at things like the mean latency calculation, the standard deviation calculation, non-optimized versus optimized. And as I said, this is have been all about different ways to optimize that strategy. This seems to be the typical approach when it comes to high frequency trading and the different concepts that they bring. Distributional latency versus optimization and non-optimization. Right here. This does an excellent job of explaining from a very, very high level how this plays out. The different types of techniques of the optimization on this simple strategy, and it's arbitrage. So we look here now, breaking it all down to the caching, L1, L2, that I mentioned before, versus the main address area. Look, I'm getting myself confused on this as well. Lucky for you, you get to watch this multiple times. Buffer data structure, inlining, SIMD, all the different times. Uh, yeah. And then we get into statistical significance, and it's just constantly evaluating on the quote unquote quant side and also on the computer science level as well. Profitability analysis is obviously the most important. Look at all the different conditions here. You have the bid, the asks. This is low level because we're not on a open high low close. We're now on the bid and ask and measuring the bid and ask spread. Cross market condition, MBBO comparison, time viability. This just goes on and on and on. This is good. This could be a really, really long video. I don't. I mean, this is the type of analysis they will do. I'm sure they have their own software that does this type of analysis as well. Again, the different types of optimization technique, which one's betterable and has a better profitability percentage on the order book. That's where your spread bid and ask spread is, and on that matching engine if you are right on the exchange. Of course, there's limitations, the disruptor evaluation, speed analysis, all the different events it takes to make this happen. Oh my God, it just goes on and on and on. On and on it goes. Cash analysis, statistical. But there you go. Conclusions. And as I said, the end notes. Thanks for watching. If you want to know more, go over and see how I do it the simpler way and get on board with the 5-day boot camp. Eventually getting released and get intro to the 45-minute Tradingview video. Thanks for watching. Over now.